Now you can start.
Yes, ma'am. Good evening, everyone. We'll continue with the paper what we were discussing in the last class. Last class, I remember we discussed the 25th question. We'll continue and finish off this paper today. So, in which of the following, wait 1 minute. So, in which of the compound bond angle is 120 degrees? A bond angle 120 degree is possible. So they've given PCl5, SF6, CH3 minus, carbanion, and none of these. Now, phosphorus pentachloride, PCl5, in PCl5, the bond angle is 120 degrees. Now, the structure of PCl5 will be this. We have 2 Cl bonded like this, and we have 2 chlorine bonded like this, and 1 more chlorine, the 5th chlorine will be bonded like this. So here in this case, chlorine, phosphorus, chlorine bond angle is 120 degrees. So any bond angle, chlorine, phosphorus, chlorine, 120 degrees. This chlorine, phosphorus, and this chlorine, this is 120. Any chlorine, phosphorus bond angle, it's 120. Therefore, the answer for this question is option 1, PCl5. The next question. Choose the incorrect order of hydrated size of the ions. Hydrated size of the ions. Now, hydrated radius. What do you mean by hydrated radius? Now, if we take NaCl, and this NaCl, when dissolved in water, it will dissociate to form Na plus and Cl minus. This is what we know. And you also should understand this. Na plus will be surrounded by water. This is called as hydration, or it is also called as solvation. It means each sodium ion will be surrounded by water molecule. Likewise, each chloride ion will be surrounded by water molecules. Now, if we take only Na plus, then we call it as ionic radius. Ionic radius. They're asking the question, hydrated size of the ions. So once the hydration is done, then what are the size of the ions, how it varies, they're asking. So the question is, the clue is hydrated radius is inversely proportional to ionic radius. Now, what does that we understand? Smaller the ion, greater is the degree of hydration. Meaning, smaller the ion, more number of water molecules will surround it. Larger the ion, less number of water molecules will surround. So this relation you should know, hydrated radius is inversely proportional to ionic radius. It means smaller the ion, greater the hydrated radius. So in case of this question, rubidium is smaller than Rb plus is smaller than potassium, and potassium is smaller than sodium. In case of the ionics, this is wrong. Sodium, rubidium is down, right? Rubidium is down. So rubidium will have greater size compared to potassium and compared to sodium. These are alkali metals. As we go down the group, the size increases. Now, the incorrect order of the question is incorrect order. Rubidium is bigger. Therefore, hydrated radius should be smaller. But here they say rubidium is larger, hydrated radius. Therefore, the answer is option 2. See, this is the order. So we have lithium, sodium, potassium, cesium, and rubidium. All these belongs to the alkali metal, the first group. As we go down the group, ionic size and atomic radii increases. Now, rubidium is larger than potassium, and potassium is larger than sodium. But what does this relation says? Hydrated radius is inversely proportional to ionic radius. So hydrated radius of rubidium will be smaller, but here they mentioned it to be larger in the second option. Therefore, the incorrect statement is this, option 2. I hope you followed. The next question. The correct statement for the reaction NH3 in ammonia, nitrogen has a lone pair of electron. When it's allowed to react with an acid, this H plus stands for an acid, we get NH4 plus. This is called as ammonium ion. It is called as ammonium ion. This is ammonia, and this is called as ammonium ion. Now, the correct statement for the reaction, hybridization state is changed, bond angle increases, ammonia acts as Lewis acid, number of bonds decreases. In ammonia, due to valential electron pair repulsion theory, the hybridization of nitrogen is sp3 and the bond angle is 107 degrees. In case of ammonium ion, the hybridization still remains same, sp3, but the bond angle is 109 degrees 5 minutes. So it is larger. NH4 has higher bond angle compared to ammonia. So the correct statement is the bond angle increases from 107 to 109 degrees 5 minutes. So therefore the answer is 2. Which of the following statement is not correct? The stability of CONH363 plus is greater than that of CONH362 6 times 2 plus. Now just observe the first statement. CONH3 6 times 3 plus. Ammonia is a neutral ligand. In coordination chemistry, we would have learned. So the charge on cobalt is plus 3 here. The second compound they have given is CONH3 6 times 2 plus. The charge on cobalt. The charge on cobalt is plus 2 here. Now remember, greater the charge on the metal ion, stability is more. So cobalt 3 plus and cobalt 2 plus. So greater the charge on metal ion, this cobalt has plus 3 charge. Therefore, this statement is correct. Among fluorine, chlorine, bromine, iodine, fluorine forms strongest complex due to its small size. The greater the charge density on the atom, hence the stability of the complex is more. Smaller the charge, greater, small F minus is small, it's smaller. Smaller the size of anion. Fluorine is an anion. Negative ion is called as anions. So amongst these 4, fluorine is small. Smaller the size of anion, greater is the charge density. Greater is the charge density. We know that fluorine is a highly electronegative element. Hence, greater stability. So the second option is also right. The third one, CONH2 plus is thermodynamically more stable than Zn2 plus. Now, Cu as we'll write it here. The third option, maybe I'll write here CuN plus and Zn NH3 4 times 2 plus. So in both the cases, the charge is 2 plus. But we know that smaller the charge. Copper is smaller, not smaller charge, size. Smaller the ion, greater is the stability. So copper is small. Therefore, copper cuprammonium complex is thermodynamically more stable. This is also right. Among the following, FeCN6 3 minus, FeH2O2 minus, and FeEN3 3 plus, FeCN6 is least stable. So FeCN6 is not the least stable. FeCN6 is the most stable. So this is the wrong statement. This is the wrong statement because they're asking the statement which is not correct. So the fourth statement is not the correct. Cyanide is a stronger ligand. So compared to water and ethylene diamide. So this is more stable than the other two. Hence the answer is option 4. The next question. Select the correct order of oxidizing nature. Select the order of oxidizing nature. Excuse me. Select the correct order of oxidizing nature. Now, if there is a concept called as effective atomic number, EAN. This EAN is calculated by the formula X minus Y plus Z. This X stands for atomic number, Y stands for oxidation number. Excuse me, Y stands for oxidation number, and Z stands for number of electrons donated by ligands. Now, if you observe this carefully, this is the complex. These two are complex. These all are not complexes. These all are molecules. So only for complexes, we can calculate the effective atomic number. In case of FeCO, CO 5 times. As a whole, the charge is 0. Carbonyl is a neutral ligand. CO is a neutral ligand. Charge is 0. And if you take iron, it is X, so X will be 0. The charge on iron is 0. Similarly, the charge on manganese is 0. Now, if you calculate the EAN of this complex, iron atomic number is 26, oxidation number is 0. Each ligand donates 2 electrons, 2 into 5 is 10. So it will be 36. Now, coming to this is for FeCO 5 times. For MnCO 5 times. So X minus Y plus Z. Manganese is 25. Oxidation number is 0. And it also has 5 ligands, 5 to 2 is 10. So it will be 35. So 36 is a noble gas configuration. 35 is lesser than noble gas configuration. Right? So therefore, the correct order, therefore, FeCO 5 times will be less compared to MnO5 in oxidizing nature. So the clue here is if effective atomic number is less than 36, 36 is the noble gas configuration, krypton. So complex is an oxidizing agent. Complex is an oxidizing agent. So therefore, the answer for this question is option 2. EAN is not there in the syllabus, 12th standard syllabus in the NCERT, but in the previous syllabus we had. So calculation of EAN, you can remember this is a simple formula X minus Y plus Z. X is atomic number. I've written here. Y is an oxidation number. You know how to find the oxidation number. I've taught you in the regular class. And Z is number of electrons donated by the ligand. Now, first you should find the coordination number. Here the coordination number is 5. So it's a monodentate ligand. So each donates 2 electrons. So 2 into 5 is 10. That is what I've written. So now each monodentate ligand donates 2 electrons. All right. So the answer for this is option 2. The next question, ionization and assertion, ionization enthalpy of early and actinoids are lower than that of early lanthanoids. 5f electrons are more effectively shielded from nuclear charge than 4f electron. Both assertion and reason are true. So this is true and this is also true. And the reason given is correct explanation. So therefore, the answer for this question is option 1. 5s electrons are more effectively shielded from the nuclear charge than 4f. Therefore, answer for this question is option 1. The next question. Match list 1 with list 2 and identify the correct option. See, in case of, where is this point to go? Yeah. In case of zinc, the atomic number is 30. In case of scandium, atomic number is 21. The electronic configuration of zinc is argon configuration 4s2 and 3d10. In case of Zn2 plus, we have argon configuration and 3d10. These two electrons will be removed. Since it is completely filled, DD transition is not possible. Likewise, if you take scandium, atomic number is 21, argon configuration 4s2 and 3d10. If you take scandium 3 plus, no, 3d1, sorry, 21 is the atomic, 3d1. So these three electrons are lost. So scandium 3 plus will have only argon configuration. Here, no d electrons. No d electrons. Therefore, no dd transition, no d electrons. Therefore, this will be colorless. So that means colorless is an aqueous solution. Which is colorless in aqueous solution? P corresponds to 4. Because Zn2 plus and scandium 3 plus have no d electrons. Scandium 3 plus has no d electrons. There's no dd transition possible. And zinc, we have 10 d electrons, completely filled orbitals. Therefore, no dd transition. The second one is they've given the magnetic moment as 5.9 Bohr magnetron. Since they've given 5.9 as the Bohr magnetron, the oxidation 5.9 is possible only when we know that mu is equal to square root of n into n plus 2. Now, if you take Fe3 plus for an example, iron, if you take atomic number is 26, you'll have argon configuration 4s2 and 3d6. Now, in case of iron 3 plus, 4s2 is lost and 1 electron from here it's lost. So it'll be argon configuration and 3d5. So 5 unpaired electrons it has. When we have 5 unpaired electrons, that will be equal to square root of 5 into 5 plus 2. So it will be 5, 7, 35, square root of 35, will be around 5.96. So similarly here also, manganese also will have unpaired, Mn2 plus also will have 5 unpaired d electrons. Therefore, both will have 5.9 as the magnetic moment. So Q corresponds to 3. Q corresponds to 3. Now, colored in solutions. Colored in solutions. So, copper 2 plus. If you take copper 2 plus, this will have electronic configuration, argon configuration, and 3d9. So, when we say 3d9, it has unpaired electron. D subshell, if you take, we have 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this one unpaired electron we will have. I'll rewrite it again. So 3d9 conflicts, when we say D subshell has 5 orbitals, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have one unpaired. So there will be DD transition according to crystal field theory. Therefore, this will be colored. Similarly, Fe3 plus also will have unpaired electrons. It will be colored. So therefore, for R, it is 1. R, it is 1. Then for S, it should be 2. S should be 2. You can calculate the magnetic moment as I calculated for Q. Hence, the answer for this question is option 2. Option. The next question, which is incorrectly matched? Which is incorrectly matched? Germanium, liquefaction, silicon, zone refining, zinc, distillation, aluminium, electro refining, which is incorrectly matched. Silicon is a metalloid. It's purified by zone refining. The zinc, silicon and germanium. See, germanium is also a metalloid, semiconductor. It has to be purified by zone refining. Here they mark it as liquefaction. Therefore, this is the wrong answer. Zinc distillation, this is correct. Aluminum electro-refining, that is also true. So therefore, the incorrectly matched is the first option, the equation. The equation is for metals with lesser melting point than the impurities. The next one, sulfur trioxide in water gives you A. 2A on heating gives you B. Find the type of bonds present in B. Now, sulfur trioxide in water gives A. A is sulfuric acid. Sulfur dioxide dissolves in water, forms sulfuric acid. This is A. Now, this 2A on heating gives B. 2A means 2 moles of sulfuric acid. When we heat, water molecule gets eliminated. We get H2S2O7. This is called as oleum, fuming sulfuric acid. The structure of oleum is this. The structure of oleum is this. Hence the answer we can see here, sulfur oxygen sulfur bond is there. So therefore the answer for this question is option 1. Next question. Moles of hydrocarbons produced by hydrolysis of 1 mole of magnesium carbide. Magnesium carbide. Let's see. Magnesium carbide, Mg2C3. This is 1 mole. Now, magnesium carbide, when we hydrolyze, they're asking moles of hydrocarbons produced. So, magnesium carbide, when we hydrolyze, we get magnesium hydroxide plus we get CH3, C triple bond H, CH triple bond CH. We get 1, 2, 3. So we get propyne. So how many moles of propyne we're getting? 1 mole of propyne. Hence the answer for this question is option 1. The next question. Consider, can you hear me? Students, can you hear me? Are you there? Can you hear me?
Yes, sir.
Yeah. Okay. Now consider the following salts. Which one, when dissolved in water, will produce basic solution? Which one, when dissolved in water, produces basic solution? Before we can answer that, we will try to understand perchloric acid, HClO4. It's a strong acid. HCl is a strong acid. HNO2 is a weak acid. This is nitrous acid. Not nitric acid. Nitric acid is a strong acid. Now, if rubidium chlorate, RbCl, potassium chlorate, rubidium chlorate, potassium, KClO3, this is rubidium. This, when we dissolve in water, we get RbOH plus we will get HClO4. This is a strong acid. This is a weak base. So therefore, this will form, since it's a strong acid, pH will be less than 7. It forms acidic solution. Likewise, if you take NH4Cl, ammonium chloride, when dissolved in water, we get ammonium hydroxide and we get HCl. This is a weak base. It's a strong acid. So pH will be less than 7 and it will be acidic. Now, when you take NaCl, we dissociate to form Na plus O and OH, Cl minus. We can get in water, it gives ammonium, sodium hydroxide and HCl. This is a strong base and this is a strong acid. Therefore, pH will be around 7. This will be neutral. They're asking which will produce a basic solution. If you take sodium nitrite in water, we get sodium hydroxide and nitrous acid. This nitrous acid is a weak acid. Sodium hydroxide is a strong base. Therefore, pH will be greater than 7. When pH is greater than 7, it will be called as a basic solution. Therefore, the answer for this question is only option 2. Only this will form a basic solution. All the other will be, all these two will be acidic. and this will be neutral. I hope that you explain. This is called as hydrolysis of salt. Whenever salt is dissolved in water, how a solution form can be acidic, basic, or neutral based on the nature of the ions present. So you should remember. Next one. Stannous oxide, stannic oxide, SnO2 plus 2H2. It's a solid and it's a gas, gives you Sn, tin, plus 2 moles of water. In equilibrium mixture, 40% water vapors is present by volume. At equilibrium mixture, 40% volume vapor is present, water vapor is present by volume. Then find Kp. Then find Kp. For gases, volume percentage will be equal to mole percentage. Volume percentage will be equal to mole percentage. So, mole of gases. So, 40% when we say 40% is 0.4. So, it will be 0.4. So, left out will be 0.6. So, partial pressure. See, the total pressure they've given us 5 atmosphere. So, partial pressure of this is 0.6 into 1 divided by 1. That will be 3 atmospheres. And here it will be 0.4 into 5 divided by 1. It will be 2 atmospheres. So Kp will be equal to pressure of water. This is a gas solid you cannot take. Pressure of water, since we have 2 moles square divided by pressure of hydrogen to the power 2, because this is also 2 moles. So it will be 2 square by, this is for water, this is for hydrogen, it will be 3 square. So it will be 4 by 9. Hence the answer for this question is option 2. The next question, as it's an assertion type question. So we have for 5F subshell, total number of nodes are for any subshell, total number of nodes are given are equal to n minus 1. So total number of nodes. Now, if we talk about a nucleus here, first orbit, second orbit, third orbit. See, these are all called as nodes, where there is no problem defining electron. Those are called as nodes. So total number of nodes are given by the formula n by n minus 1. This is correct. Now they're asking for the 5F subshell, total number of nodes are. So it will be n minus 1. That is 5 minus 1. That will be equal to 4. So the answers, both A and R are correct, but R is not the correct explanation. R is the correct explanation, so it's wrong. It's wrong. A is correct, but R is not. R is the correct explanation, therefore this is also wrong. A is incorrect. R is correct. Because A, they have given only 3. But as for the formula, we need to have 4 nodes. 4 nodes. So therefore, the correct answer for this question is option 3. The next question. Correct matching of column 1 with column 2. NEET, match the following has been asked regularly. So they're asking correct matching of column 1 with column 2. Arsenic sulfide, sulfur salt, starch salt, colloidal soap. So arsenic sulfide is a multi-molecular colloid. It's a colloid, molecules. Sulfur salt Colloidal soap, we will come back. Colloids of soap is a macromolecular, soap-Michel formation. So it's a macromolecular colloid. So A and D we have learned. So sulfur salt we have. Now starch and sulfur. Sulfur is an associated colloid. Starch is a lyophobic colloid. Therefore, A is matching R, B is matching S, C corresponds to P, and P corresponds to Q. So therefore, the answer is option 3. The next question. The diagram given below is a vapor pressure composition diagram. For a binary solution A and B, in a solution A and B interaction are similar to AA interaction and BB interaction, greater than AA interaction and BB interaction, weaker than AA interaction and BB interaction, and unpredictable. So this is based on the deviation of solution from ideal behavior, or we can say non-ideal solution. Non-ideal solution. So you can see here, for a non-ideal solution, the vapor pressure increases. That means in this case, it is weaker than AA and BB interaction. What is this AA? Solute, and this is solvent. So if the solute-solvent interaction is less than solute-solute interaction or solvent-to-solvent interaction, then the vapor pressure composition diagram is this. This is a solution showing positive deviation, a non-ideal solution showing positive deviation. That is option 3. The next question. Optically active tartaric acid is named as D plus tartaric acid because it has positive optical rotation. Because it has positive optical rotation and derived from D-glucose, pH is an organic solvent. Optical rotation and its configuration is related to D plus glyceraldehyde. Optical rotation only when substituted by deuterium. So tartaric acid, we have, this is the representation of tartaric acid. One of the forms I'm writing. So this will be the rotation. So this form is optically active. The other forms of tartaric acid is not optically active. This is because the optical rotation and its configuration is related to T plus glyceraldehyde. Therefore, the answer for this question is option 3. Next question. Find reactivity towards electrophilic addition. So the relation is reactivity of electrophilic addition reaction is proportional to stability of carbocation. We know that tertiary carbocation is stable than secondary is stable than primary, and primary is stable than methyl carbocation. So find the reactivity to its electrophilic addition reactions here. The answer is option 4. R is more stable compared to Q, and Q is more stable reactive compared to P, and P is more reactive compared to S. It's based on the stability of the carbocation. Hence, the answer is option 4 for this question. Find out the type of carbon atoms present. The next question. Propanol with phosphorus tribromide, alcoholic potassium hydroxide, hydrogen bromide, and ammonia. It's a lengthy reaction. So this is propanol. This propanol when allowed to react with PBr3, phosphorus tribromide, this OH is replaced by Br. So the product what we get is we get CH3, CH2, CH2, and Br. This is A. When this is allowed to react with alcoholic KOH, dehydrohalogenation takes place. So this Br and this hydrogen is removed. So we get CH3, CH, and you'll have a double bond formed here. So we get propene. This propene, when it's allowed to, this is B. When this is allowed to react with, where is that point? HBr, hydrogen bromide, Markovnikov rule. So negative part of the added molecule gets bonded to carbon containing less number of hydrogen. You get CH3, CHBr, and the double bond breaks, and this hydrogen attacks this carbon. So we get CH3. This is C. This when it's allowed to react with ammonia. This when you allow it to react with ammonia. One of the hydrogen, ammonia I'll write like this for our understanding. So this H and Br gets eliminated. In place of Br, NH2 goes. So we get CH3, CH, NH2, and CH3. So therefore, the answer for this question is option 2, the second option. The second option here. So it is amine. The next question. Which product is not formed in the given reaction? So this is C6H5 CONH2. It is amide. When amide is allowed to react with NaOBr, it is Hoffman's bromide reaction. Hoffman's bromide reaction. So this CO is removed. So you get C6H5NH2. Conversion of amide to amine is called as Hoffman's bromide reaction. This is A. When this is allowed to react with sodium nitrate in HCl, it's diazotization reaction. So diazotization reaction, you get benzene diazonium chloride, C6H5N2Cl. This is B. When this benzene diazonium chloride is hydrolyzed, the product we get is phenol. This is C. And this when we brominate, this OH group is an electron donating group. Therefore, it directs the reaction to take place at ortho and para. So you get Br, Br, and Br. So you will get 2, 4, 6 trinitrophenol. 2, 4, 6 trinitrophenol. Hence, the answer for this question is option. They've given one of the product here. One of the product they've given, para. So therefore, the answer is option 4. Because nowhere bromine is shown. So it's a tricky question. So you should get this in bromine water. But they've given only this as an option. Next, this is a simple question. That is C6H5CH2 benzyl chloride when it's allowed to react with sodium cyanide. So this Cl and Na gets eliminated and Cn gets bonded in place of Cl. So you get C6H5, CH2, and Cn. When this is reduced using DiBALH and followed by hydrolysis, we get C6H5, CH2, and CHO. Cyanide is hydrolyzed to aldehyde. Therefore, the product what we get is option 4. It's an aldol. It's an aldol. The next one, the IUPAC name of the complex. The IUPAC name of the complex. The complex they've given us Ag, NH3 twice, and you have AgCN twice. So it will be diamine, 2-amine, diamine, silver. It's a cation here. So it will be 1, And here, cyanide, argentate. It's an anion here. This is coordination isomerism. And here also argentate will have oxidation number 1. Silver will have oxidation number 1. But here it's named as silver. Here it is named as argentate. Hence the answer for this question is option 4. The next question, which of the following statement is correct? Which of the following statement is correct? PT and NO3 twice, EN twice. Complex ion shows linkage isomerism. So here, no ambidentate ligand. So in this complex, we have no ambidentate ligand. So since ethylene diamine and NO3 is not an ambidentate, it cannot show linkage isomerism. But they say it can show. Therefore, this is a wrong statement, but they're asking us the wrong statement only. Therefore, the answer is option 1. All the other is fine. Bromine will react with silver nitrate to form pale yellow precipitate, and this shows hydrate isomerism. This will show structural isomerism. All the other options are right. Next question. Match the following and identify the correct option. CO plus H2. CO plus H2 is called as synthesis gas or syn gas. CO plus H2 is called syn gas, synthetic or synthesis gas. Na6P6O18 is called as calgon. B2H6 is called as electron borohydride. It's an electron deficient hydride. And H2O2 is non-planar. It has a folded book-like structure, non-planar structure. Therefore, the answer for this question is option 4. The next question, by which of the following reaction is inorganic benzene prepared? Which of the following reaction? So, borane and ammonia in the ratio 1:2. When we heat, we get B3N3H6. This is called as inorganic benzene. Inorganic benzene. Therefore, the answer for this question is option 3. The last question. Correct match. Inert gas. A as the configuration. Helium is 1:2 or other group of elements NS2, NP, 6, 8 electron series. A is Q. Representative elements. First and S block and the P block elements can be called as a representative element. So B here is P. P is P. And C, D block elements. D block elements will have a general electronic configuration in this N-1, D1 to 10, NS0, 1 to 2. This is S. Inner transition element is F block element. It'll be R, since we have F orbitals here. F orbitals. Therefore, the answer for this question is option 3. So this ends the second set of paper for discussion. So I think we'll stop the class. We'll continue with the next. Now I'll stop the class.